Today, we're driving into another breakthrough that sounds like science fiction, but is happening right now in Austin, Texas. It looks like we are finally moving past spell checking our DNA and moving toward replace all button for incurable diseases. Researchers have developed a new technology called gene editing Retrons that is roughly 20 times more efficient than current methods. Instead of fixing one tiny genetic typo at a time, this tool can swap out entire paragraphs of faulty DNA safely. This could be the key to curing complex diseases like cystic fibrosis that have stumped scientists for decades. What do you think about this, John?
I love this, and strictly because they talk about cystic fibrosis, and I lost a sister to cystic fibrosis. But regardless, I love it because, and by the way, I think it's pronounced Retrons, but I could be wrong. Who knows? So this is exciting because many genetic diseases like CF, they're caused by hundreds or even thousands of different mutations. So current gene editing tools like CRISPR, they can typically only fix one or two specific mutations. So that means that therapies work for some patients, but leave many others behind. So the new Retron-based system can replace large defective sections of DNA with healthy versions, which means that you could potentially treat patients with different mutation combinations using a single therapy. And this is staggering, the improvement here, because previous attempts to use Retrons in human cells only worked about 1.5% of the time. This new method succeeds about 30% of targeted cells with potential for even higher rates. So this could democratize gene therapy by making it financially viable to treat rare mutation combinations that affect small patient populations. I absolutely am excited for this. This is great. What are your thoughts on this?
I think this is amazing. We're getting all sorts of new gene editing tools now that, they've done much more to map a genome, and we have tools like CRISPR, and this really takes CRISPR to the next level where, like CRISPR is like checking for one specific typo in a document. This is like, replacing a whole paragraph or page at a time with a fully corrected version, which means you can move through things so much faster. There's less, I guess, cuts, maybe, for lack of a better word, because you're doing it in bulk. And I'm not 100% sure if that's true, just because I don't know how that works exactly. But the precision and control offers more precise precision and control. I don't know why I can't say that this morning. To conventional gene editing techniques, this precision comes from natural cellular processes that guide DNA replacement mechanism. This system works well with existing machinery rather than forcing foreign processes. So all these changes make it, the 20-fold increase in why it's working like 20-fold times better. Or
Exactly.
Yeah. So it's cheaper. Cures more, broader, could do hemophilia, Tay-Sachs, other complex genetic conditions. Go ahead, John.
Yeah. So for those of you that still don't get how awesome this is, imagine this. Imagine having a genetic disease, but being told that while a cure exists, it wasn't designed for your specific version of the disease. So that's essentially the reality for thousands of patients with genetic disorders like cystic fibrosis, where over 1,000 different mutations can cause the same disease. What we're seeing with this Retron breakthrough is essentially the development of universal gene therapy, one treatment that could work across hundreds of different mutation types. And that's the key here. And like they've already achieved 30% accuracy. I love this. I think they're on a path. They could get close to 100. But obviously, there's some regulatory pathways, some safety considerations. So what the FDA has established is they've established precedents for gene editing therapies, right? But Retron's approach with RNA-based delivery and the lack of permanent DNA integration, it could actually enable faster regulatory pathways. And the lipid nanoparticle delivery system, it already has extensive safety data from COVID vaccine deployment. So that could potentially reduce regulatory hurdles compared to viral vector approaches that we've covered before. So I think this is huge. I think this is amazing. I think This has real promise to get somewhere viable sooner rather than later.
Yeah, currently it's really expensive, even though the goal is to make it cheaper. Early gene therapies are historically incredibly expensive. I think once they start narrowing it down and finalizing it, it'll get cheaper when they productize it, I guess. I'm really looking forward to this. I'm like, stuff coming out of Texas is amazing these days. Some of the university studies and MIT and the things that could potentially be solved by this. I'm really excited about this technology and where we're potentially going to go with it. At the same time, I guess there's always what happens if this kind of thing gets in the wrong hands.
For sure.
Yeah. So that's a potential scary thing, but let's leave that for another day. How about that?
Yeah. So like, just to kind of put this, you were talking about how expensive it is, right? So the first CRISPR gene editing therapy that was approved by the FDA in December of 2023 for treating sickle cell disease, that was a price tag of between $2 to $3 million per patient. And the company says this is because the treatment regimen is so complex. It involves hospital stay, doctors remove the bone marrow, edit the cells, and then transplant them back. And so this complex procedure highlights why simpler, more accessible approaches like the Retrons system are really needed. So like, there are systems out there, again, like we talked about, but those are specific. They're not multifaceted as far as what they can handle. They're like one or two mutations, right? So hopefully, or if this is more of a multi-mutation approach, that will reduce the cost, but we'll see.
Absolutely. And, this bacterial retrons allow scientists, or retrons allow scientists to edit genes with unprecedented efficiency and precision in living cells. So this opens new doors for treating a whole bunch of genetic diseases once considered completely incurable by medicine. It's incredible to see how we are borrowing tools from bacteria to fix our own code. We'll be watching at U of T in Austin closely to see when this moves from fish tanks to pharmacies, and we'll let you know. What do you got going on, John?
Yeah, just gearing up. Is this coming out in December?
Yeah, December, might even be January now, actually.
Okay, gearing up for the holidays or gearing down from the holidays. So planning out my next few months and, ramping up for shred season. How about you, Craig?
Well, we're wrapping up 2025 and planning 2026. So this is probably too late for the Start Investor Drinks and Flowgrammer events in December, but take a look for them in January. There's always stuff going on. Check out torontostarts.com for our startup and business related events and resources, and check out flowgrammer.ca for our business and AI automation information if you're looking for that. And if you're a builder in Toronto and you want to join the Flowgrammer Builders Club, head over to flowgrammers.ca. That website is live now. Go check it out. Join us at our live events. We do online stuff. We do live office hours every week. Go over there and sign up. There's downloaded workflows and tools you can test and play with. So check all that stuff out. But John, if people are looking for non-dilutive funding, where do they go?
Yeah, come find me on LinkedIn. I've got a link. You can book some time with me or send me a message so that we can have a conversation first. But find me on LinkedIn, John Irwin, no H. But if you need help with your business overall, with your startup, how do they get in touch with you, Craig?
Head over to startupcoach.ca or torontostarts.com and just book a call with me and get a discovery call, find out what's going on and get you motivated. If you're not interested in that, come out to one of our events, talk to other founders and whatnot, and just talk to people. It really is, knowing that you're not alone can motivate you a lot. But other than that, give us a call or book a meeting over at torontostarts.com. And thanks everyone for listening or watching, and hope to talk to you again soon.